These are the solutions for Melham's Calculus 1, Math 251 at College of San Mateo, the Chapter 3 exam. Number 1, f of x is equal to square root of x, which is the same as x to the 1/2 power, and you're given the point 16, 4. F prime of x is 1/2 x to the negative 1/2, or 1/2 radical x. Plug in 16, 1/2 radical 16, 1/2 times 4, 1/8. So I have the point 16, 4, slope 1/8, y minus y1 equals m times x minus x1. Y minus 4 equals 1/8 x minus 16. Number 2, differentiate. So x squared minus x over x plus 1. So denominator, x plus 1 times the derivative of the numerator, which is 2x minus 1, minus the numerator, x squared minus x, times the derivative of the denominator, which is 1, all over x plus 1 squared. This one's easy to work out, so we should do it. 2x squared plus x minus 1 minus x squared plus x over x plus 1 squared. So x squared plus 2x minus 1 over x plus 1 squared. Number 3, you basically just have the 6 trig functions and put their derivatives. So that's really all there is to it. So y prime is cosine x minus sine x plus secant squared x minus cosecant squared x plus secant x tangent x minus cosecant x cotangent x. Number 4, f of t is 2 raised to the t sine of 3t. So f prime of t is 2t raised to the t sine 3t times natural log of 2. Then by the chain root times the derivative of the exponent, which is first times the derivative of the second, t times cosine 3t times the derivative of 3t, which is 3, plus sine of 3t times the derivative of the first function, which is 1. And that's basically it. A little bit of touch-up, put the 3 in front over here. So 2 to the t sine 3t ln 2 times 3t cosine of 3t plus sine of 3t. Number 5, x squared plus 3xy minus y squared is equal to 21. Differentiate implicitly. So 2x plus product root 3x times the derivative of y, 1 times dy dx, plus second function y times the derivative of the first, derivative of 3x is 3, minus 2y dy dx equals 0. The terms that don't have a dy dx go stay on this side since they're both positive. So I left 2x and 3y on this side. I moved the dy dx's to the right side to have fewer negative signs. So that one goes over, it becomes a negative. That one goes over, it becomes a positive. So I have 2y minus 3x dy dx divided by 2y minus 3x. So dy dx is 2x plus 3y all over 2y minus 3x. Okay, number 6. Looks like I didn't have it here. So f of x equals x to the x power. So call that y equals x to the x. Take the natural log of both sides. So ln. Once you have the ln, the x can come down in front. Ln y equals x ln x. So the left side's always the same. 1 over y dy dx equals a product rule. First times the derivative of the second, plus second times the derivative of the first, but that's just 1, so I don't have to write anything. And just multiply both sides by y. Cancels out, but you don't leave it as y, you write what it originally was, which was x to the x. So dy dx is equal to y, x to the x, and that cancels out, leaving with 1 plus ln x for number 6. Number 7, you have s of t is t squared minus 10t, t greater than or equal to 0. When is the particle at rest? That means velocity equals 0. So I simply take the derivative, 2t minus 10, set it equal to 0, t is equal to 5. And they don't give us any time period like seconds or minutes or hours, so we don't have to put anything. Just leave it as t equals 5. Okay, number 8, you're given the initial amount is 100 milligrams. So A of t is 100 e to the RT. Half-life is 5730. So 5730 goes here. Half of 100 is 50. That goes here. Divide by 100. 0.5 is e to the 5730r. Take the natural log of both sides. ln of 0.5 is ln e to the 5730r. That cancels out. ln of 0.5 is 5730r. Divided by 5730. R is natural log of 0.5 divided by 5730. It's about negative 0.000121. So that climbs back up for R, way back over here. So A of t is 100 e to the negative 0.000121 t. Okay, so now we're asked what happens after 100 years. Plug in 100 right here. So A of 100 is 100 e to the negative 0.000121 times 100. Punch it in your calculator. It's about 98.8 milligrams. Number 9, you have one car going west 30 miles an hour. The other goes north at 40 miles an hour. I call that X. I call that Y. Here's the hypotenuse. And let's see, after 4 hours, so 4 hours at 30 miles an hour means 120 miles. 4 hours at 40 miles an hour is 160 miles. Okay, you can do your x squared plus y squared equals z squared to find the hypotenuse. 120 squared plus 160 squared is equal to z squared. That comes out to be 200. So 2x dx dt plus 2y dy dt equals 2z dz dt. Divide by 2z, the 2's cancel out. X dx dt plus y dy dt divided by z is equal to dz dt. So I plug in x is 120, dx dt is 30, y is 160, dy dt is 40, divided by z, which is 200. Punch it in your machine, 50 miles an hour. Number 10, approximate 2.01 to the third power using the linearization. So f of x is x cubed. At x equals 2, y is 8, so 2 comma 8. F prime is 3x squared. Plug in 2. 3 times 2 squared is 12. That's the slope. Y minus y1 equals m times x minus x1. Add 8 to both sides. Y is equal to 12x minus 16. That's L of x, the linearization function. So to approximate 2.01 cubed, I do L of 2.01. I basically plug in here. So 12 times 2.01 minus 16 comes out to be 8.12. And finally, 11, find basically cosh of x prime, prove that it's sinh. So cosh x prime is e to the x plus e to the negative x divided by 2 prime. And it's best not to do the quotient rule, factor out the 1/2. So it's 1/2 e to the x plus e to the negative x prime. So the derivative is 1/2 e to the x minus e to the negative x. Rewrite it as e to the x minus e to the negative x divided by 2. And that's a definition of sinh. All right, so those are the solutions for Melham's Math 251, Calc 1, Math 251 at CSM.